Hello everyone. I hope everyone is fine. So today we are going to attempt this paper. It's 0478 and variant is 12. We have three variants here, 11, 12 and 13. The paper is of Feb March 2025, right? It's a computer system paper, paper 1, right? So question number 1, uh, let me tell you one more thing. Besides attempting this paper, I'll tell you something about the concepts, right? So stick with me. So complete the sentence about number systems. Use the items from the list. Some of the items in the list will not be used. You should only use an item once. It means you cannot use one letter twice, right? So let's see, it's about A, B, C, D, and 1, 2, 3, 1, 2, 4, 8, 16, 30, whatever, right? So it's about fill in the blanks. The binary number system is base dash. Now you need to understand what is binary. Binary mean we have two numbers, 0 and 1, or the combination of 1, 0, 0, 1, right? No other number is included in it, right? So that's why we call it binary. So the base is 2 because we have only two numbers, right? So the binary number system is base 2 system, right? The smallest binary number that can be represented as an 8-bit binary number is, first you need to understand what is binary number. Binary number are decimal number systems. We have numbers starting from 0, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and the base is 10. Binary number system or decimal number system, we have 10 numbers there, including 0, right? So it says the smallest binary number that can be represented as an 8-bit binary number is, what is the smallest number? That is 0, right? The largest binary number that can be represented as an 8-bit binary number. So this is asking you about the binary number, the largest number, binary number that can be represented in 8-bit binary number. So let me show you. Say for example, we have this 8-bit binary registers 1, 2, 3, 4, 5, 6, 7, 8, right? So if I turn on all the bits and if you place the formula just above it, the binary formula course, I suppose you know it, 1, 2, 4, 8, 16, 32, 64, and 128. If you add all of them, then the largest number you would get, that is 255, right? The hexadecimal number system, this is another number system that is included in your syllabus. We have binary number system, binary number system, and decimal number system, right? So hexadecimal number means we have 16 numbers in hexadecimal starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we use A, B, C, D, E, F, rather numbers, right? A represented 10, B represented 11, and so on. The last digit, that is 15, which is equal to F. And the total numbers we have in hexadecimal numbers, we have 16, right? So the base is 16. Students, listen, these are the basic concepts, right? So the examiner actually checks your basic concepts. Up till now, he is talking about the binary system, the very first lesson of your syllabus, right? The hexadecimal number system is base 16. Okay. Each hexadecimal digit, no matter it's a 9, A, 1, 0, F, whatever he's saying, each hexadecimal digit is equivalent to what? How many bits? Okay. Now this is the concept you have to understand, right? So we have 16 numbers in hexa or hex number system. We have 16 numbers. So how many bits we need to accommodate all these digits? Let me tell you. 1, 2, 4, 8. The very first digit is, that is 0, 0, 0, 0. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And the last one would be, that would be 1, 1, 1, 1, which means that is equal to F. F mean, if I can write this in binary, that is 15. So double one, it represents F. F mean 15, right? So to adjust the hexadecimal number system's digits, we need 4 bits. Every number in hexadecimal number, no matter it's 9, say for example, if I say A, which is 10, so we do write this 1, 2, 4, 8. 8 plus 2, 10. That's it. So that is equal to 10, means we need 4 bits to accommodate every hexa number, right? I hope that it's clear, right? So the number 1 to 9 are used and the number 10 is represented by, I just told you, that is A is equal to 10, right? The numbers 1 to 9 are used and the number 10 is represented by A, because he is still stick to the point which is hexadecimal number. The hexadecimal number system continues up to the number 15, which is represented by F, right? So I hope this clears you very much. Now let's move on to the part B of question number 1. So two 8-bit binary numbers are given. So this is the number. Add the two 8-bit binary numbers using binary addition. Give your answer in binary. Show all your working. So let me tell you the basic concepts of this. We have carries when we add binary numbers. So you have to understand that 1, 2, 4, 8 and all that, right? So how do we write 0 in binary? Definitely 0, 0. How do we write 1? I'll place 1 just below 1 and the next bit will be off, which is 0. How do we write 2 in binary? I'll place 1 just below 2 and I'll place 0 just below 1. So that is equal to 2, binary 2. And how do we write 3? 2 plus 1, that is 3. So 2 plus 1, that is 3, right? Clear? 2 plus 1, that is equal to 3. So now that would be easy to understand now. 1 plus 1, 2. What is 2? This one. Normally, student call it 10, but I do disagree because it's a conceptual error. So you must know that is we are dealing with the binary, so it should be 0 and 1. So I'll be taking this 0 over here and this one, that will be carry forward, right? Now we have 1 plus 1 plus 1, 3. How do we write 3? 1, 1. So 1, I'll be placing 1 here and 1 will be carry forward. So 1 plus 0 plus 0, that is 1. 1 plus 0, that is 1. 1 plus 1, that is 0, 1. So I'll be taking this 0 here and this 1 will be moved to carry forward. 1 plus 0 plus 0, that is 1. 0 plus 0, 0. 1 plus 0, 1. Right? So 1 0, 1 0, 1 0, 1 0, triple 1 0. So there is another method you need to make sure, if you want to make sure that is that being correctly added. So you can convert this number into denary, then this number as well, and you can make sure that you have converted this binary numbers well. I hope this is clear. So this is binary addition can result in overflow. Overflow, what does it mean, overflow? So say for example, we have a glass of water. So if you continue to pour water in this glass, at one point it starts filtering, right? It's spilled. So that water, the excessive water, that is called overflow, which means that is going to be lost. Remember that, okay? Tick one box to show the correct definition of overflow in binary addition. The answer has created a negative number that cannot be represented in binary addition. Negative number. No. Negative number is talking about complements, two's complements, so this won't be happening. The second option is the answer is the result of a logical shift that cannot be performed in the binary addition. No, it doesn't make any sense. The answer is too large to represent in the number of bits available. Yes, this makes sense. So this glass of water is not a big one which can be accommodated more water. Let me say this one is a simple example, right? So in order to adjust that overflow, you need a bigger glass of water or a jug, let me say. So just like that, say for example, if we have 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. So the maximum value it can have, that is 1, 1, 1, 1, 1, 1, 1, 1, which is equal to 255. So let me give you an example. This is basic concept. That's why I am focusing on this, right? Say for example, we have this number, binary number 1010 1010, right? And then we have 11110000. 0 plus 0, that is 0. 1 plus 0, 1. 0 plus 0, 0. 1 plus 0, 0. Sorry. 1 plus 0, 1. 0 plus 1, 1. 1 plus 1, 2. 0, 1 carry. 1 plus 0 plus 1, 2. 0, 1 carry. 1, 2, 3. So this is 3. So how many bits we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that value is going to be overflowed. The bit will be lost. So that gives you inaccurate answer. So this is called overflow. So actually we cannot accommodate these numbers in 8 bits. So we have another bits which is the 9th bit, right? I hope that is clear now. Shall we move? Okay, this is question number 2. Question number 2, it says an artist creates an image on a computer. Okay. State what is meant by the color depth of an image. State. By the way, you must know what does it mean state, what does it mean by explain, what does it mean by describe. So you have to understand them, right, while attempting the paper. Okay, state what is meant by the color depth of an image. That is of 1 mark. Say, for example, we have this image. What is meant by color depth of that image? Color depth means how many colors are in this picture. So it means, so that depends on the number of bits. For a colorful picture, you have at least 2 to the power 8 bits, and that gives you 256 colors. 2 to the power 9, that gives you 512. 2 to the power 10 means that gives you 1024. So it means the number of colors that is directly dependent on the number of bits. Is that clear? So we can write that the number of bits, the number of bits used to represent each color of an image. The number of used to represent each color of an image, right? So that is the color depth, right? So the B part, describe the relationship between the resolution of the image and the file size. This is just I told you about that. So if you can look over here, if we increase the number of bits 2 to the power 8, 2 to the power 9, 2 to the power 10, then we can have more colors, which means you increase the number of bits, we can have more colors. When we have more colors, then the definitely and ultimately the size of the image that will be increased. If you lower the color, if you decrease the number of colors, then it means the quality, you are compromised on the quality. So which means now the file size of that an image that will be reduced, right? So we can write that the higher the resolution, more more pixels we have to store. That impact on the increase in the file size. Okay, for example, we have 720 by 1024. So it's a number of pixel resolution. So if we make it like 1024 multiplied by 2048, that gives you a very good quality. So definitely the size of that an image that will be like it will take more space in the file, right? like 2 MB, 4 MB and all that, right? So uh, part C. The artist compresses the image file before uploading it to their website. Before uploading it to their website, users can download the image file from the website to print as a poster. Print as a poster. Okay. The image file is compressed using lossless compression. The image file is compressed using lossless compression. Explain the reasons why the artist chose lossless compression instead of lossy compression to compress this image file. Students, I believe that you know there are two types of compression, lossy and lossless. Lossless means we cannot compromise on the quality of the image. We cannot compromise on the quality of the data, right? It compresses the data, but without loss. That's lossless. Whereas in lossy, we have to compromise on an image or on a video. We can compromise on the quality. For example, we can have a movie of 1 hour in 700 MB, and the same duration movie we can have 4 GB, right? So what exactly is the difference between the two versions? That is the quality. Definitely in 4 GB of movie that would have like more colors and a very good resolution. So here the artist, he doesn't want to lose the quality because he wants the other user to print as a poster. So that's why he doesn't want to lose the pixels of that poster, right? And the second thing he is saying, he compresses this before uploading it, right? So what does it mean? Say, for example, the size of that image is 10 MB. Let me say, so 10 MB. After compressing the file, let me say, after compressing that the size would be 3 MB. It's just an example, right? So after compressing that file, what happens? What exactly the impact on the file after compression? Definitely, the file size will be reduced. File size will be reduced. Number one. Number two, it won't take too much time to download and upload the image. Is that clear? Okay. And in lossy, I told you we lost the quality, but in lossless, we do not lose the quality. So transmission will be fast, of course, definitely, because the file size is reduced, so it takes less time, right? And the artist want what? He wants to provide high quality image. Is that clear? So I guess we are done. So, and the third thing I can write. So on servers, it doesn't take so much space, right? Because, you know, the compressed files, it doesn't take too much space. 3 MB, 10 MB, there is a difference, of course. So the server has enough space to store the image. Clear? Let's move on. Identify one lossless method of compressing an image. Lossless, there is a very famous, that is in your syllabus, lossless method of compressing an image, that is called RLE, run length encoding, right? Run length encoding. Describe your chosen method, that is RLE. So description, we can write uh, RLE, run length encoding. It's an algorithm, right? Run length encoding is a lossless compression algorithm. So what exactly does this algorithm works? It find out the repeated pattern, repeated pattern of colors, because we are discussing image. So that's why I am saying repeated pattern of colors, right? And make them the repeated colors, they are given a particular number, the number of repetition, how many times it's repeating, and consecutive consecutive pixels. Oh, I am already done that. Sorry. Now let me give you an example, right? For example, we have this image. Say, for example, this one is black, this one is black, this one is black, right? So these are repeating actually. So how does this algorithm works? It find out the same color repeating, that is one white, two white, three, four. So we have four white, then we have two colored. Say for example, it's red. Then we have one white and two red, right? So total number of boxes, let me say box. So we have nine, two, four, then we have six, seven. So we actually saves two boxes. So when we have more like a big pattern, then we can save a lot of space. You can find out in your the books which is recommended by your school, right? So let's move on. The artist emails the image file to their friend. Okay. Explain how a file is broken down into packets and transmitted over a network. So let me show you an diagram first. That would be easy to understand, right? Say, for example, this is my computer, uh, MPC, my computer, and I need to send this email, or let me say this is artist computer, and this one is the client or the people who is going to download the image, right? So when he send this image to his friend, what happens? The data, the file, the image, that will be splitted into chunks. We call it datagrams or packets. Every packet has some information, right? Every packet is divided into three parts, though there is a lot of information in one packet. But in your syllabus, we have these three important things, that is header, then we have payload, then we have trailer, right? In header, we have the IP addresses of the sender and receiver. I am not writing this like I'm using short form, so just to save the time. IP addresses of the senders and receivers, the packet numbers, payload, it contains the data, the actual one actually, and the normally the packet size is that is split into, that is divided into 64 KB. And trailer has some other information. For example, it has a error reduction method that is called CRC, cyclic redundancy check, plus it identify the end of the packet, identify the end of the packet. Is that clear? Good. So these packets, these now transmits over different routers over the internet. So this sign, this is representing a router, right? That's not mandatory that all these packets will be transmitting over the same route, right? So there is a possibility this packet 3 will be transmitted through router 5, and this packet, maybe let me say packet 2, will be routed through the other router, right? So router, what is a router? It's a hardware device, an expensive word, right? Router, it determines the route, which means it find out the shortest path for the packet, shortest path for the packet. There is another field in the packet that is called hop number. Hop number means which identify that every packet can have like hops, for example 10. If it doesn't find any destination after 10 hops, then that packet will be automatically discarded, which means that would be discarded, means that would be overlooked or that would not be considered, because if that packet roaming around the net, which means that is going to be created some kind of congestion and network traffic, which makes the network slow and not optimized. I hope you understand the concept of the packet switching, right? So the very first point is, shall I write this? Okay, let me write that. Data is split into small packets into chunks. Normally we call them datagrams. DG means datagrams, right? Datagram, packet, it's the same thing. Then every packet has some information. Just I told you about, that's header, then it has payload, then it has trailer. And the third point is these packets transmitted over the internet by using different types of hardware devices. We call them routers, right? And router is it's a hardware machine which determines the best way to push the packet to its destination, which is this one, right? Destination. We can have more routers, right? So it's a actually it's a lengthy topic. I cannot cover this in this question. So at the destination, the packets will be rearranged. Rearranged mean they can be received by this receiver in this form 5, 4, 3, 2, 1, and when the client has to rearrange them into 1, 2, 3, 4, 5, so so that he can see the same thing that is submitted or dispatched by the artist, right? So I guess shortest path, we have also done that, right? So I believe that you remember that I just drew this diagram just to let you know the concept of packet switching. Otherwise, you just need to write down the points, right? I hope that's clear now. So the next one is the packets can use many different methods, okay, of data transmission to travel or transmit. Complete and annotate the diagram. It means you have to write the some important things on this diagram so that one can easily understand. To show the difference between the serial full duplex transmission between two computers and a parallel simplex transmission between two computers. By the way, that is very, very simple because these are the modes of data transmission: full duplex, simplex. These are the modes, and this is the, sorry, serial and parallel. These are the methods, and serial, half duplex, full duplex, simplex, these are the direction of the data. Serial mean one wire, one bit at a time, right? Full duplex mean both way. Full duplex mean both way, right? And what is serial? Serial mean one wire, right? So the data can be transmitted over one wire or channel, and the data both ways same time. Clear? Parallel. Parallel means we have multiple wires or channels. Normally we have 8 channels or wires in parallel mode. 1, 2, 3, 4, 5, 6, 7, 8. That is multiple wires or channels, only one direction, only one way. You know it, right? Simplex means only one way, either side, from computer 1 to computer 2 or computer 2 to computer 1. Clear? Is that clear? Okay. So let's move on to the last part of this question, question number 2. Sorry, are we done? Yes, we are done with the question number 2. This is question number 3. A computer has a central processing unit, memory, and secondary storage. Part A, The computer has a von Neumann architecture. By the way, this is very important topic in your syllabus. Circle three registers that are found in the von Neumann architecture. So let me say this one is central processing unit. So we have program counter register which holds the address of the next instruction. Then that address is forwarded to MAR. Then it find out the data from the memory, right? A memory has address and the contents are data, right? Data. So it find out the data against that address that would be transmitted to the MDR, memory data register, MDR. Then a copy is sent to CIR, control current instruction register. Then we have other registers as well. For example, we have ALU inside that, then we have accumulator, right? So let me see the registers over here in the list. We have to find out, we have to circle actually three registers. Accumulator, yes, it says circle. Circle means circle. You should not be writing this. You should not be writing this. Okay, so we have to circle the appropriate registers. Accumulator, binary register, current instruction register. Okay, that is also the register we can find out in the CPU. Logical register, no. Arithmetic register, no. Control register, no. Data counter, no. Program counter, yes. Binary counter, no. Current data register, no. Instruction counter, no. Yeah, no. Okay. So we have these three registers in the CPU, right? So now these are the questions which gives you free marks, right? So that is very simple. I believe everybody of you knows about what are these core system. So what is the difference between a quad core computer and dual core, right? And the generation as well. So in part B, it asks you state the purpose. What is the purpose of the CPU in the computer? That is very simple. CPU process the instruction and so and it processes the instruction and later on that gives you output on your screen, LCD or LED, whatever, right? Or we can say it performs a fetch, decode, execute cycle. That's okay too. Process the instruction. Process the instruction means definitely that is supposed to get the data from any input device, right? So that data is actually processed by the CPU, and later on that gives you a result on your LCD, LED, or you can say that it performs an FDE cycle, right? Decode, execute cycle. Okay. So part C, computer A has 2.1 gigahertz. Students, you need to make sure that you are attempting this question very carefully, right? You need to understand that here the question that gives you that tries actually that tries to give you a big what should I say, confuse you in simple words, right? Computer A has 2.1 gigahertz. Quad core processor means it has four cores. Four cores means one core is equal to, that is, one control unit and one ALU and some of the registers. That is one core, right? So it means that 2.1 gigahertz processor has four cores, which means four CU, four ALU, and other registers. Whereas in computer B, it has 2.5 gigahertz, which means the capacity or the performance, the clock cycle, clock cycle of computer B, that is 2.5 billions of clock cycle, that is greater than 2.1, and it has only two cores, right? Two cores. Whereas computer C has 5.2 gigahertz single core, which means it has only one ALU, one CU, and some of the registers. Core, it has only one core. But the capacity, that is the powerful, it's a very powerful processor because it can generate 5.2 billions of clock cycles, right? Gigahertz, giga means 2 ki power 30, that is equal to 1 giga. So we are measuring speed, that is hertz, right? So identify which computer is most likely to execute more instructions simultaneously. Now you are confused, right? If you try to attempt this question in Hazel, then you would be in trouble. That question would be going to hurt you because you will be losing marks, right? So more instructions simultaneously means we have four cores and every core can perform one FDE. Core means it can perform four FDE cycles simultaneously. So the option will be computer A. Is that clear? Now you can, in justification, you can write because it has four cores and each core, each core will be executing one instruction at a time, one instruction at a time. And the third point is, you can say more instructions can be executed per second. Clear? I hope you understand the point. So here is another one that is going to confuse you, but you should be like very attentive. The examiner cannot give you a tough time if you are attempting this paper very cool, carefully and vigilant. Explain why computer C can execute more instructions per second than computer B. So that's very simple. The clock speed, of course, let me show you again. Computer C, it has 5.2 gigahertz, and the computer B has 2.5 gigahertz. Computer C has the double speed of computer B. So it has a higher, computer C has a higher clock speed, and it can perform more FDE cycles per second. Because of its speed, more instructions can be executed per second, just because of its speed, right? Clear? Okay. Now let's move to question number. Oh, we have the same question. Still, we have part D. All three computers have the same instruction set. Define the term instruction set. Instruction set, actually, let me tell you, this is, though it's not in your syllabus, instruction set, if you can give it attention, then let me tell you, instruction set that is composed of opcode and operand. Opcode mean the operation which is going to be done over these operands, right? So this is just a command in your syllabus. You just need to memorize this. It's a command that is supposed to be processed by the processor. That's it. It's a command or commands or instructions. It's the same thing that can be processed by the CPU. Okay, question number 4. It's a very interesting one. You have to understand the question. Whenever the question comes in your paper, just like the scenario can be changed, but he normally asks about this thing, sensor, the kind of the sensor, then the data, because sensors gives you the data in analog form that is supposed to be converted into ADC, analog to digital converter does this thing. Then the value after conversion, that is compared by the CPU with the pre-stored value that might be stored in the database, right? So what happens if the value is greater or less? Then the CPU can take the action. It can be a monitoring kind of control, or it's a control situation, right? So let's see this question. An automated teller machine, it's ATM, banking ATM, of course, is a device where a person inserts their bank card, debit card, or credit card and can request to withdraw money. Okay, that's fine. Then the ATM also allows the person to check how much money they have in their bank account. Okay, that's fine. We can see the balance on the ATM machine. Part A. A sensor is used to detect when a person stands within 1 meter of the ATM. These are the very important parameters, right? Because you are going to mention this thing in your answer, right? I don't know what is that, but we'll see. When a person is detected, a welcome message is displayed on the screen. Okay, that's fine. Identify an appropriate sensor for the ATM to use to detect a person. Okay, there can be more than one sensor. Uh, Motion sensor, that's okay. Motion sensor. Then if you write infrared, then it's fine too. And maybe proximity sensor. Okay. So describe the role of the microprocessor in detecting the person. Describe the role of microprocessor. CPU receives the data from sensors in analog form. CPU receives the data from sensors in analog form, and then this data is supposed to be converted in binary form, in binary, so that computer can understand that through ADC, right? Okay. Now infrared sensor, when, if you can notice this, a sensor is used to detect when a person stands within 1 meter of the ATM. Now sensors uses data uses the data to calculate distance, right? So how does this happens? Definitely it compares the value, it compares the value with the stored value. If it is less than 1 meter, if it is stored value, if it is less than 1 meter, 1 meter, then what happens? The person is detected, person is detected, and the message displays. Message displays on the screen. Clear? Describe the feature of the ATM that identify it as an embedded system. Embedded system, right? You know it, and I firmly believe that you know the difference between embedded system and the systems which uses a full-fledged system, for example, Linux, Windows, and all that, right? So an embedded system, it's a complete system having microcontroller and some kind of RAM, ROM, and it performs a particular or specific function. For example, vending machines, automatic washing machines, oven, micro oven, and all that, right? So describe the features of the ATM that identify it as an embedded system, right? So we can say features of the ATM because ATM can perform only one function, that is you can withdraw the money or you can transfer by using the panel. It performs dedicated functions and uh, ATM that is used for special purpose, special designed for special purpose, special purpose machine or device because it can perform only one task, right? And what other I can write that? So yes, that is important. Dedicated hardware. Dedicated hardware. It has an actuator which is used to pull the money. Of course, you can pull the money from the ATM machine, and it can have. I don't know. I didn't see inside what is exactly is inside the ATM machine, right? So there must be some kind of thing like trays which makes the tray just very close to the point where you get the money, right? So it has a machine which performs a particular function, right? A special purpose machine, dedicated function because it performs only specific task. And I guess that's enough. We are good to go. Part C. The ATM has a touch screen and a keyboard. Normally, these ATM has the same things. The ATM may need to be used by the people who are unable to see. Who are unable to see means, say for example, let's say a user is blind, and we know that for blind persons, we have this keypad. Really, keypad or talking about if it's desktop, then it's really keyboard, right? And identify one other input device and one output device that can be built into the ATM to help people who are unable to see. So we can write really keypad and the speaker, right? Though it can output can have the headphone as well, but the question comes, if a blind person is there, how can he see the headphone? Yeah, there might be a chance someone told him that it's on the left side or right side. So that's okay too. So it's question number 5. A computer is connected to a network. Okay, the computer has a network interface card that has a media access control address. Okay, it's a MAC address. One purpose of the NIC is to provide the computer with a MAC address. Okay, MAC address, it look like it's a 6-byte address. We know it, right? 6-byte or 48 bits address. This is already given. We are not going to write this thing on its the purpose, right? So NIC network interface card, which is also known as physical address, right? Physical address, MAC address, built-in address, network address, it's the same thing, right? So it is asking you describe the other purposes of the NIC. What is the purpose? what is the purpose of NIC? The very important is that allows it allows your computer to have a physical connection between a PC and a network, right? That connection can be like it's a wired or it can be a wireless. It can be a wired or it can be a wireless, right? And the second point is, say for example, this is your computer, right? We are on the LAN. LAN means local area network. We suppose we are sitting in one room, a big room actually, in an office. So our computers are connected through wires. So these are the desktop computers, and these are connected through Ethernet cables. We call it LAN cables. LAN cables. So physical connection, that gives a physical connection between a computer and a network. Now we can share the data from one computer to another by using this connection, right? No matter it's a wired or wireless. Okay. So what is the purpose, second purpose of the NIC? NIC, this computer has NIC, this one also has an NIC. Every computer, every gadget which has a MAC address, it can be connected through on a network, right? So this NIC actually receives the data. It can receives the data from any device on the network. Okay. Number three. After receiving the data, then what happens? NIC then it convert data. It converts the data, what should I write? In a form that is to be transmitted over the network. What does it mean? Say for example, if your computer, say for example, it's you are sending some data to this computer, then this data will be converted in a form so that it can be transmitted over the LAN by using different protocols, and that is received by the other computer, right? Okay, identify three characteristics of MAC addresses. Earlier I told you that the size of the MAC address is, it's a 6-byte address. It's a 6-byte or 48-bit address that is represented that is represented in hexadecimal numbers. Hex numbers, for example, E43266C 1 2 colon 3D 0F, right? So first bytes, first three bytes represent manufacturer. It represents manufacturer ID, and the last 3 bytes that represent the serial number of the device. The last 3 bytes represents serial number of the device, and MAC address is also used. That is very simple. Yes, you can write another colon is used. Numbers are separated. These hexa numbers, sorry, these hex numbers are separated by colon. Okay. So we are good now. The the B part of this question, the network allocates an IP address to the computer. IP address, it's a logical address, right? That can be changed. Say, for example, you change the internet service provider, your IP will be changed, right? Say, for example, if you are in school and you are using some gadgets, then you can have like a different IP. Then if you go back to your home and then you connect your device to your home network, then you would have a different private IP. So it's a logical IP that uh, so people can find your location by your public IP. So what are these public, private, and all that? That's not the part of our discussion and your syllabus, right? So IP address, it's a logical address and it can be changed, right? So how does it look like? IPv4. V4 mean version 4, so we can have 4-byte address. For example, uh, 10.2 sorry 10.200.100.30, which means 1 byte. 1B mean 1 byte, that is of the second byte, third byte, and fourth byte, which means total we have 32-bit address. IP address, the size of the IP address is, it's a address of 32 bits or 4 byte. 4 byte. So 1 byte mean we can have maximum numbers from 0 to 255. Any number that is greater than that. And the second thing is that it's Denry number. It has only Denry numbers. It doesn't have any like hexa number. And these numbers are separated by dots. Let me give you another example. 192.132.100.2, right? Dot, dot, dot. Okay, so 110 colon. Colon means this one. That is not valid. So it says tick one box to identify. So I am not going to cross any of them. I just need to find out the correct one. So just to let you know, okay, where is the error? That's why I'm writing this. Okay, the second one is 1.30.2FF. 2FF, this cannot be the part, this cannot be the part of the IPv4. So that is wrong, absolutely wrong. 3.162.74.3. So it looks valid to me because this IP address is separated by dots, 1 byte, 2 byte, 3 byte, and the fourth byte. Yes, all numbers are within the range from 0 to 255, and these are separated by dots. So the fourth one is, let me say, 8.0.257 dot. So 257, it's invalid. 257, it's invalid, right? It's invalid. So C is the answer. I hope you understand the question, right? So let's move on to the next part. Sorry. Identify the device in a network that can automatically assign an IP address to a computer each time the computer connects to the network. So, listen, boys and girls, my purpose is not like that you feel, my students feel uh, some kind of the situation, they feel bored. Actually, I'm explaining this because you must know all these things, right? So it's a question of 1 mark, but that is related to the DNS, DHCP, DHCP, and the router. You must know these things, right? Our home routers assigns us the IP address so that we can be connected with the net and we can be a part of the global world and we can share the data. So the routers we have at home, actually that has an option inside that is DHCP, Dynamic Host Control Protocol. This assigns you the address, right? So router here, our router assigns us the IP addresses, right? So all these settings, the settings of DHCP and the firewall, there are MAC binding and all that, firewall, that this router can be configured, right? So router actually that assigns us the IP address to our mobiles and to our desktop computer or laptops, right? So C, a user accesses the World Wide Web using a web browser. Web browser mean it's an application software. So it can be Opera, it can be Edge, Firefox, or Safari, whatever you, Google Chrome, whatever you like, right? So you are actually accessing, you open a web browser, then what happens? Define the term World Wide Web. Definitely, we know that because we are the computer students, and we know that whenever we type the URL, we see these things: HTTPS, then this thing www.cnn.com. Hypertext Transfer Protocol secured, and this colon and this forward slash World Wide Web. Actually, you are accessing the information from the different web servers, right? And web servers can have millions of websites, right? Which can be accessed by the users. And these websites, web servers are hosted by the ISPs. ISPs mean Internet Service Providers. So let me write that. A collection of websites, collection of millions and billions of websites and web pages accessed by the users, right? Using internet, definitely using internet. If you are not connected to the internet, then you cannot access the resources on the internet, right? So normally these websites are hosted, they are stored on the web servers, and web servers can be accessed, they can housed in the ISPs, internet service providers, right? Clear? Okay. Question number, okay, the same question, we are doing the same question. Next part is the uniform resource locator, URL. URL and the web address, it's the same thing. Website address, web address, it's the same thing, right? Uniform, in some places you can even find out unique resource locator. URL for a website includes the protocol, hypertext transfer protocol, secure. I just told you about that, right? So this one. Explain how HTTPS makes the transmission of data secure. So let me give you an example. HTTPS, then you can see a log just after that. It means the data between your browser and the web server that is secured by some protocols, right? So what is the question? Explain how HTTPS makes the transmission of data secure. Okay, it uses a latest protocol. It uses a latest protocol. If you even do not write this latest, then it's fine too. That is TSL, sorry. TSL, and the older version is secure socket layer, right? Okay, the data is encrypted while using the protocol. Encrypted data, or it encryption is done. Encrypted data, let me short it. And how can it make that transmission of data secure? Then it uses different types of encryption. And in your syllabus, you know, we have symmetric encryption and asymmetric. And we know asymmetric, that is much better than symmetric, because it uses two keys, public keys and private keys, right? It uses asymmetric encryption that makes your data meaningless, right? A public key, definitely a public key that is transmitted, public key is transmitted with the data along the data, which can be decrypted by the private key. Decryption key is used at the receiver end. Decryption key is used by the destination computer by using private key. Is that clear? In this case, destination means web server. I think we are done. So we have this one point, it uses protocol, the secure protocol, that is TSL and SSL. It makes your data meaningless, which means it encrypted the data. What is the form of the encryption? It encrypted your data. Normally, asymmetric encryption is used, and data is encrypted using the web server public key, of course, and the data is decrypted by the web server private key. Okay, I believe that you understand the points. Now, the next part of this question is the protocol is one part of the URL. Give the other two parts of the URL. If you can notice that this is very, very easy. Say, for example, the protocol is one part of the URL. Let me write down the full address. HTTPS www.cnn.home.html, for example. So this one is protocol. It says we are done with that. So this is World Wide Web, and we call it domain host, right? This one is domain host, and this one is website address or domain name. .com, it's a commercial website. .org, org mean organization. .uk mean United Kingdom. .gov. If you find out cnn.gov, it's just an example, right? Gov means it's a government website, right? If you see cnn.net, so it means it's a network of CNN, right? So this is called, there are different, the options while selecting your domain, right? And it's the directory, right? Web page name, web page, or file name or directory, file name or directory, right? So domain host, it's a domain name or website address, or this can be a web page, or it's a file name or directory. Clear? Okay, let's move on to question number 6. A search engine. So while attempting the question paper, when it says anything important, for example, a search engine, it should come in your mind. He's talking about Google, Alta Vista, Yahoo, Lycos, and Bing, sorry, not Bingo. So a search engine uses artificial intelligence to identify the most relevant web pages for the users. Yes, we know that AI is a part of syllabus. One characteristics of AI is the ability to learn. Okay, yes, we understand, we agree. Identify 3 other characteristics of AI. Dear students, you need to learn about the advantages, disadvantages, characteristics of all these things. These things mean artificial intelligence, robotics, machine learning. So here he's talking about the characteristics of AI. So we know that one of the feature or characteristic is that is it is ability is to learn, right? And the other can be a collection of the data from the different resources, collection of the data from different resources, from different resources, and it sets up the rules for the data, and it should have ability to adapt and reason, ability to uh, and the fourth one is ability to adapt, right? So if you need to learn something about these things, talking about emerging technologies, you can find out these topics on my channel, YouTube channel, CS by, you know, Mirza Asim. That's in very detail, and I hope you can understand. I expressed all the things and the parts and the contents of the chapter number 6. Chapter number 6 means emerging technologies I'm talking about, right? So all the stuff about AI, robotics, and machine learning and all that, right? So let's move on to B part. It says the search engine uses machine learning, right? Okay. Explain how machine learning is used by the search engine. Number one, how machine learning is used by the search engine, right? It uses rules, it uses rules and it can change the data according to results or feedback. It can search engine machine learning, it can supervised and unsupervised learning, definitely from the different resources. It uses algorithms, algorithms. It uses algorithms to decide what comes first in the search, right? Rules, and it can use the data according to the results and feedback, supervised and supervised learning, and it uses algorithms to decide what comes first in the search. And okay, so I hope you understand this part. Question number 7. So programs can be written in high level language or a low level language, right? High level languages are those languages which are written in where the programmer writes the code in English words. For example, input, output, print, if, then, else, etc., etc. Right? So level languages, it's assembly language and it's machine language, right? Assembly language and machine code. And high level language, it can be like Visual Basic, it can be Python, it can be Perl, it can be C++, etc., etc. Right? Machine code is one type of low-level language. Identify one other type of low-level language. Identify the translator that is needed for the type of low-level language you have identified. Type of the low-level language, as I said, assembly language. You need skills to understand the assembly language, right? It's assembly language, and the translator it uses to translate the code into machine code, that is assembler. That is also known translator. You know it, right? We have three types of translators. One of them is assembler, which is only used in assembly language, right? Whereas there are others. The second one is compiler, and the third one is translator. There are some differences between them, so you need to understand the difference as well, right? Okay, let's move on to the question number 7, part B. A high-level language can be translated into low-level language using a compiler or an interpreter. Okay, that's fine. Describe the advantages of using an interpreter instead of compiler using software development. Okay, so uh, let me tell you QBasic, GW Basic, these are the high-level languages, and these languages, they use interpreter. So I'm running out of time. Otherwise, I have an intention to show you the demo. How do we use these instruction and interpreter? So now let me tell you briefly on this paper. So interpreter, while using interpreter, each statement, each statement is translated. Translated. Why translated? So that computer can understand that into binary. Each statement is translated and executed before the next. For example, let me write two of the commands here. Say, for example, print. Print. Print mean output statement, right? How, sorry, enter number. Let's say enter numbers. It's an output statement, which means that message will be displayed on your screen, and input num. This is another statement, right? So what happens? Interpreter interprets or translate every and single statement one by one. If it finds any error, say for example, if unintentionally a programmer violates the rule of the language, for example, by writing some incorrect reserve word, for example, INPUT, INPUT. So it doesn't make sense, right? So the interpreter stuck here, it stops there, and it will not be moving on the next line until you fix it, right? So it means that is very, very beneficial for at the time of the development, because the programmer can find out the error at this stage, they can fix it, and they can move to the next line or the next part of the program, right? The second point, it can be translator or interpreter stops stops when an error occurs and and it stays there until you fix it, right? Until you fix it, right? You make it correct, then it will be on the next statement, right? Okay. uh, that is very helpful in the development phase, because the programmer can fix the errors at the early stage, right? Okay. It does, after fixing the error, it does not require you, does not require retranslation. It starts translating from the very next line after you fix the error, right? So that is it. Let's move on to the third part, that is C part. Integrated development environment provide translators. Listen, everyone, IDE that is available normally in all high-level languages, right? For example, if you are using Visual Basic, or if you are using Python, C++, Perl, Ruby, and all that, so that gives you different types of options, right? You can have you can have some debugging options, you can have indentation, pretty printing, you can have some tools to watch the variables values and all that, right? So IDE, that is called integrated development environment. Now what is the question? It asks you identify three other common functions of IDE. Number one, you can write the code, you can write the program in the code editor. The place we write the program, that is called code editor. Where you write the, where programmer write the code. That is provided by all IDE in all high-level languages, right? Believing that that language has IDE environment, right? And uh, IDE also now provide you a very good feature, that is autocomplete. Autocomplete. You have noticed this thing. This also comes in your mobile, right? Say, for example, you are texting someone. So, uh, for example, you when you write hello, what's up, what's, then it automatically complete, and you need to press the tab button or space button, that automatically complete the sentence. So that is also, this feature is also available in IDE. And auto correction, that makes your spellings automatically correct. So that provides you another feature, pretty printing, which means that some of the code you are writing, maybe that is on the in the blue color, and green might be using for the comments, and red can be used for different purposes. So that gives you, that helps you to identify the code easily. That's why that is introduced in every normally high level languages, right? So pretty printing, so that also provide you a facility of pressing this button plus and this minus button to collapse and expand. So vice versa, collapse or expand. right? So there is another feature, auto documentation, which can automatically document your code. Auto documentation. And some languages also gives you line number 1, 2, 3, line number 517. If you are writing a very long code, then some of the languages they give you a line number as well, right? So that gives you some debugging tools as well, debugging tools to find out the error and fix them. So that's it. Now let's move on to, oh, we are done. So that is it. I hope that you understand the paper, and I believe that you like it. I tried to convey the concepts as well, so that's why it took long. As earlier, I was expecting that I might be like finishing this paper within 1 hour 30 minutes, but by the explaining other things out of this paper, the concepts things, that took some time, right? So hope you don't mind it, and I believe that you share the video, and I'll be uploading definitely paper 2 very soon, so that you can have a better understanding. So I'll be keep expressing the concepts so that you can be good in the concepts, and you can easily attempt the paper, right? So take very good care of yourself. Till now, bye bye.